Good morning, guys, or good evening. So, in our last session, we have discussed what exactly Elastic Network Interface is and user data, metadata options in our EC2. So, here in today's session, we are going to start discussing about the Elastic Load Balancer. So, any questions before starting the session, guys?
Avinash,
Yeah, I have a question.
that
Yeah,
user
so yeah, go ahead.
that user data and metadata, if someone knows our public IP, can they access it?
See, whoever connected to your EC2 instance, only they can execute those commands, right? So whoever got access, like whoever logged into that operating system, yes, they will come to know about private IP as well as public IP. So, but most of our resource, we don't associate public IP address that we run our all resource in private subnet that we will discuss in our VPC section. What is public IP? What is private IP? How we can get connected to only private IP EC2 instances and all. That we will discuss in our VPC.
Yeah. Mm. I have another question. So take an example. We have created 100 VMs and we need to tell them like we need to do a system upgradation or we need to update our website or pages that displaying on each and every VM. So how we can do it? How we can perform the task?
We can do by using systems manager that we will talk in a couple of sessions later.
Okay. And
Otherwise, if you want to go with the AMI, golden AMI mechanism, if it is a new instance, all our new EC2 instances, you can go and perform by using golden AMI. Otherwise, you already have EC2 instances. Suddenly, let's assume you want to install one package
Mhm.
in all the 100 EC2 instances, or you got a patch for all the Windows EC2 instance, or you got a security update for all the Linux instances. So in all these scenarios, we're going to depend on systems manager. Remotely without logging to your EC2 instance by giving a tag, you can execute any command. So that we will discuss in our coming sessions.
And yesterday I tried to run that script that we learned it yesterday. And when I'm stopping my VM and on that time, like after stopping, I can edit that like that command. And if I try to change my web page, it's not reflecting. It's not taking the new command. It's taking the old commands only.
It won't reflect if it is a Linux instance. For that, you need to implement another module called Cloud Init. So Cloud Init user data need to be added. So then only it will. So that I clearly mentioned before that itself, right? I mentioned that. So you need to add this Cloud Init module within this user data and all, then only it's going to. Otherwise, it won't.
No, it's a different package that we need to install on that machine first, and then it will approve.
Yes.
It is on system level, like AWS console level, or it's on machine level.
In
The way.
user data itself, you need to. In user data, first you need to initialize Cloud Init, then you can execute. If it is a Windows, it's straightforward. Whenever you are giving persist to true, then it is going to install after every reboot. If you stop instance, if you modify it, after next reboot, those changes are going to take effect.
Okay. Okay. I will look into it. Thank you.
Right. So I have seen Manoj, your query in our Slack channel. So I don't find any issue here. Why? Because your service is in running state here, first thing.
Right.
And I can say your service is not started as a logon service, but your website is not loading and port number 80 also is open. So
Yeah.
let's do one thing. If you still have that resource up and running, let's have that. We will check end of the session. So otherwise, just try to launch an EC2 instance and make it as a web server. and use the same security group with the same port numbers, we will see what exactly.
Okay. Yeah.
If that ready, at end of the session, before closing the session, we will check that issue if it is not fixed.
Yeah, sure.
Okay. Right. So here in today's session, we are going to start with the elastic load balancer. So basically, as I mentioned, we are going to have two types of scalings: vertical scaling . Yeah, basically, I lost the power connectivity. So connected through my mobile phone. So till the power restored, we will use this. Right. So when coming to this vertical scaling, so this is in simple, it is upgrading same EC2 instance. So upgrading or adding resources to the same EC2 instance. That is a vertical scaling. Horizontal scaling. When coming to horizontal scaling, scaling application with multiple EC2 instances. So you have an application, instead of running that with only one EC2 instance, you can take two EC2 instances and you can deliver your application with two EC2 instances. The advantage is if something happened to that one of the EC2 instance, so you still have another EC2 instance that is up and running. So that is the mechanism here. Right. So when coming to this elastic load balancer, we have total 3 types of elastic load balancers. So the real difference is supported protocols. One is classic ELB. Second one is application ELB. This also called as ALB, application load balancer. Network ELB. This also called as a NLB, network load balancer. This is basically previous generation one. In simple, you can say that is an outdated one. So 90% of the times we are going to use application load balancer only. Then recently, among these 3, network load balancer is a recent one from last 1 year. We got that. So we can use that network load balancer. Right. So I'm going to explain all the 3. The important or the big thing here is the supported protocols. When coming to application load balancer, it works with only HTTP and HTTPS protocols. When coming to network load balancer, it works with TCP protocol, TLS protocol, or TCP underscore UDP protocols. So the supported protocol is matter. Okay, so when coming to this, if your application is developed to use or consume HTTP protocol, then you need to choose application load balancer. If your application is developed and it is working on TCP protocol, for example, Windows Kerberos authentication that uses TCP protocol. So you must go with the network elastic load balancer only. If you take application load balancer, it won't deliver that. So such type of limitations we have. So we are not the one who decides that. Application team, we are going to check with them, okay, what is the protocol they're using, they use to design that application, their application is going to consume. Based on that, we are going to choose this. When coming to Classic, it supports all the legacy protocols. So either it is HTTP, HTTPS, TCP, UDP, it supports all the protocols, right? So now, how this load balance is going to work high levelly, we are going to discuss now. So when coming to this high level, so this is one of the EC2 instance. This is another EC2 instance. So now we have an elastic load balancer. So whenever end customer is trying to access our application, so instead of directly connecting to EC2 instance, he must connect it to ELB. So then this ELB is going to connect to our EC2 instance and is going to take the traffic and it is going to deliver to end customer. So the advantage here is if something happened to this EC2 instance, this load balancer will stop sending data to that. How this load balancer will come to know about that? So basically this load balancer continuously checks the health status of this EC2 instance. So to verify whether that instance is a healthy or not, it continuously ping. For example, I want to check my internet status from my local machine. So I'm going to ping google.com. So whenever we are pinging google.com, so it's going to take some traffic and it is going to ping like, that website and what exactly. So will it gives replay or not? So that depends on like, I'll show you that seems my phone, I have restricted this ICMP traffic. So I just got the power connectivity and I will connect to my network. Give me 2 minutes. So this continuously, this load balancer will go and will ping this EC2 instance. And we need to define the path. So, okay, this load balancer will go and ping our EC2 instance to what file or to what path it is going to ping. Okay, in our website, in our EC2 instance, the default web page is going to be index.html. We can ping to that. Otherwise, at enterprise level, we are going to take a dedicated web page, status.html. So for example, index.html is the entry point for our web server. So many requests are coming. So you really don't want to go with that file. So simple, create another simple HTML file with the name called status.html. You can give it. So you can ping to any of the file. And on what port number you want to ping? Okay, I want to ping on port number 80. So now this load balancer will go and pings this EC2 instance continuously. How frequently it is going to ping? And within how many seconds it need to give replay whenever we are trying to ping to the EC2 instance? 1 second, guys. Okay, I hope you guys are able to see my screen now.
Yes.
Yeah. So now I'm pinging google.com. See here I'm getting responses. So what is happening from my local laptop? One packet is generating and that packet is traveling over the internet and it is reaching the Google server. From Google, I'm getting response within 18 milliseconds, 19 milliseconds and all. So my machine sent four pockets received by Google, 0% loss and average, internet is 18 milliseconds. So my internet is constant and stable, I can say here, right? So similarly, this load balancer continuously ping to our EC2 instance, and this EC2 instance need to give reply within 2 seconds. That is response. So that response should be, response time is going to be 2 seconds. So whenever it is pinging, it need to give reply within 2 seconds. Now, one request came and we got reply. Fine. So how frequently this load balancer need to check? Okay, now it is checking. After 10 seconds, again it is going to checking. Another after 10 seconds, it is going to check. Like, or for every 30 seconds, I want to go and check health status of my EC2 instance. So for every particular duration, repeatedly, I want to check status of this EC2 instance. So that mechanism, request intervals. So what is a health check interval you want to give? For example, for every 10 seconds, I want to perform a health check. So now this load balancer will go and check the health check, and it need to give reply within 2 seconds. Now it will wait for a 10 seconds. After 10 seconds, again it will go and it will check. Again it will wait for 10 seconds. Again it will go and it will check. For every 10 seconds, this health check is going to happen. Right. So this duration, how much duration you want to give for from health check to health check? That is a health check interval. Now, so you're going to take only one health check to declare that instance as a healthy or unhealthy? No, right? For example, two continuous health checks failure happen, this load balancer need to stop sending traffic. For example, this health check got failed. Okay, one health check is failed. This health check also failed. Two health check failed. So then immediately, okay, seems there is an issue with our EC2 instance. This load balancer will stop sending traffic to that EC2 instance. So how many consecutive health checks, successful ones you require to declare that instance as a healthy? Failure ones you require to declare that as a unhealthy. That mechanism, we call it as a healthy threshold and unhealthy thresholds. So for example, healthy thresholds, I'm giving 5. 5 consecutive health checks are success, then only this elastic load balancer will declare the instance as a healthy. When coming to unhealthy thresholds, I'm going to give 3. That means 3 consecutive health check failure happen, then this load balancer declare the EC2 instance as unhealthy, it won't stop sending. So it keep on performing the health checks on our load balance. This load balancer keep performing the health checks on our EC2 instance. For every 10 seconds, it will go and it will perform it. Within 2 seconds, we need to get response from the EC2 instance, and it is going to this EC2 instance. It will verify this particular file over this particular path. It is going to ping to that particular path. So this is the mechanism happens in backend. Right? So any questions on this mechanism, guys?
What happens if both of them health status is not good?
It stops sending traffic to both the servers. You're going to get 503 error and all, service down or service not available, request timed out errors. We should have at least one healthy instance to deliver our application to end customer. And Amazon always recommend you to spread our EC2 instance across multiple availability zones. So for example, your EC2 instance, one is running in 1A, another one you can keep in 1B. So for high availability purpose, right? So let me quickly launch a couple of EC2 instances. So one I'm going to launch in 1A, another one I'm going to launch in 1B. So then we will configure this elastic load balancer. So whatever the user data we have used in our last session, same user data I'm going to use, but I'm going to change that bit. So I'm going to call this as this is my instance 1. Okay, so launch instance, and I'm going to take Amazon X2 AMI, T2 micro, and I'm going to choose episode 1A here and scroll down to the bottom and the user data. Then click on next, add storage and web server 1. Click on next. So I'm going to create a dedicated security group for this web server. So I'll tell you why. So web server SG. There is a reason for this. So make sure you open port number 80. Otherwise it won't work. Review and launch using an existing key pair. Right. So now let me launch web server 2 also. Amazon Linux 2 AMI, T2 micro, AP South 1B. 1C won't support T2 micro, guys. Whenever you're trying to launch T2 micro in AP South 1C, it won't support. So that's why always I prefer to go with AP South 1A or 1B. Right, let's scroll down to the bottom and let me grab this. And I'm going to call it as a web server 2. You might get a doubt. Why you are giving different web pages? Why can't we have a central data for all these web servers? Those all we will discuss. I want to demonstrate that your traffic is going to both the web servers. That's why I'm giving web server 1 here. I'm giving web server 2 here. Then click on next, add storage 8 gigs. And here web server 2. Then I'm going to choose same security group, web server SG. Review launching using an existing key pair. So now let's go and verify the output of web server 1 and web server 2. See here, this is my instance 1. We are able to get that output. So instance 1 is good. Let's wait for this instance 2. Once it is up and running, test the output, then we will jump in and configure our load balancer. So tomorrow we are going to discuss a topic called auto scaling group. For example, this EC2 instance is down due to some reasons. So we have a mechanism called auto scaling group. If you implement what happened, another new EC2 instance is going to create. If you delete both the instances, 2 more new instances will come. If you delete these 100 times, 101 times, you are going to get 2 more EC2 instances. That mechanism we call it as an auto scaling group. So that you can treat it as a phase 2 on this load balancer. This is an introduction one. Let's grab the public IP address and go and deliver it here. And there you can see we are able to get the output. So both of the web servers are working fine. Now let's navigate to load balancer. Here we have load balancing. Navigate to load balancers. Click on create load balancer. So I'll tell you backend mechanism of this load balancer. Whatever the subnets where exactly your resources are running in that availability zone, we are going to get network interface cards. See how many NIC cards we have now? Only 2. One is web server 1 and web server 2. So let's forget about it. Now come back to load balancer, create load balancer. So the first I'm going to take, okay, a new one came. This is a classic load balancer actually. Choose a gateway load balancer when you need to deploy and manage fleet of third-party virtual appliances that support appliance enabled to improve. Okay, here is a classic load balancer. This I need to verify. Why? Because for previous batch also, like from 15 days back also, we don't have this. Same cities for OSI model. Okay, I'll come back on that. So let me scroll down and let me pick classic load balancer first. Okay, let me update this one also. We got a gateway elastic load balancer. So now let me pick classic load balancer first. Create. What is the name you want to give? So you can give a name. So classic ELB is the name I'm giving. In what VPC you want to run this? In my default VPC, I want to run this. So we have only one VPC at moment. So just go with that. Create an internal load balancer. This internal load balancer means, so your load balancer works within your VPC environment, within AWS environment only, this load balancer is going to work. See, it's just like a intranet. See, intranet and internet. Intranet, it works within the network, right? Within your organizational network or within the network only, it is going to that website. But internet works across the globe. Works across the globe. So whenever you're selecting this particular feature, create an internal load balancer. This works as intranet website. So you will get a DNS name. The DNS name won't resolve from outside world. That is a mechanism. Okay. So I want to test from my local machine. I even want you guys to test my website. So I'm not going to select it as an internal load balancer. So then enable advanced VPC configuration. When coming to this advanced VPC configuration, whenever you select this, here we are going to get an option. What are the subnets you want to select? Like where exactly your EC2 instance are running and all that we need to select. If you don't select this, automatically Amazon is going to pick all those options. So let me enable this advanced VPC configuration. Then here my EC2 instances are running in episode 1A as well as 1B. So in future, if you are going to launch EC2 instance in 1C, you want to make 1C also part of the load balancer, you can select that one also. So you can select all the three or 1A or 1B. See, it is recommended to choose minimum two, select at least two subnets in different zones to provide higher availability of our load balancer. So how many subnets you are going to select, or in how many resource our load balance, how many subnets our resource are running, those many NIC cards here it creates. Okay, so now I selected 1A and 1B. Now load balancer is going to use port number 80. So if you want to implement HTTPS protocol, you need to associate a SSL or TLS certificate. So this SSL or TLS certificate, we are going to discuss when we discuss a topic called ACM, Amazon Certificate Manager. See, I have a certificate. If I just want to show you, I can go here in next step. I can choose a certificate. Here, configure security settings. I can go here and I can select a certificate. But again, you will come back with a question. Hey, Avinash, have you got this certificate and where to generate and all? So that we will discuss as a different service. So at moment, go with the port number 80. So port number 80 is a default for any website. Just go with that. So now I selected both the subnets. Then if you want, you can select all the three also. Then click on next. So here for this load balancer, what security group you want to give? So that security group you need to associate here. So click on create new security group. I'm going to create a new security group for this load balancer also. ELBSG, Elastic Load Balancer Security Group. I have given name as a ELBSG. Port number 80 is open for everyone. Okay. You must open this, guys. Otherwise, your website won't deliver to outside users. This load balancer is a internet facing and anyone can get access to your application by using this only, right? So you must open all this port number. So then click on next. So this is step 3, security settings. So as we are not opening any HTTPS or SSL protocols or certificates, this is going to give a little warning. Just ignore this warning. As I have shown, I can simply go and I can pick that, but that we will discuss in our ACM, Amazon Certificate Manager. So ignore this at moment. Then click on next. So here, now we are going to configure these things. So what is a ping protocol it is going to use? It is going to use HTTP protocol. Ping port, it is going to ping to port number 80. What is a path? It is going to ping to index.html. Now, whenever this ping operation is going to happen, what is the response duration or response timeout is a value you are expecting here that. So the response is here it is 5 seconds. I'm going to make it as a 2 seconds. That means whenever my load balancer perform health check here, it need to give reply within 2 seconds. First thing. Interval, how frequently? For every 10 seconds it want to. So that is an interval value. So okay, I'm going to give every 10 seconds. For every 10 seconds, it will go and perform the health check. Right? So then how many unhealthy thresholds? For example, 2 continuous health check failed, that instance is healthy. I'm going to make it as a 3. Healthy thresholds, I'm going to make it as a 5. So for every 10 seconds, it is going to perform health check and it needs 3 health checks to declare that instances are unhealthy. So basically, we will go with the least values for unhealthy and interval also. Least values is a 5 seconds. So now within 10 seconds, my load balancer will detect this EC2 instance as a unhealthy. So within 25 seconds, it will declare that instance as a healthy. Okay, so these are the values. So you can give minimum values all here or go with the default. That doesn't matter. That we really don't care. We just go with the default values. But I want you to understand this. So now click on next. So what are all the EC2 instances you want to add on top of this load balancer? See, now also we have EC2 instances. We have EC2 instances, but did we add any communication between these? No. Now here we are going to add. I'm going to add web server 1 as well as web server 2 to this load balancer. I'll talk about this. Okay. So I have, for example, you don't selected this web server 2. So only web server 1 is going to send traffic to the load balancer. So I'm going to select both. Then click on next. What is the tag you want to give? So name tag you can give like, test application or load balancer, what application you want to give, you can give all those things. Then click on review. This is a review screen. It is a classic load balancer. It is an internet facing one. Whatever the traffic coming on port number 80, it is going to send load balancer to port number 80. So we are going to perform health check to index.html. So this load balancer need to give replay within 2 seconds. For every 5 seconds, it will go and perform the health check. 2 consecutive health check failed, that instance is unhealthy. 2 consecutive health checks are success, that instance is healthy. So we have added 2 load balancers on top of 2 EC2 instances to this load balancer. Connection draining and all, we will talk about that. So then on what VPC it is running, what are all the subnets you made it as, and what security group you have given to this load balancer. Get that, click on create. So now the load balancer is being created. So here you can find the load balancer. See, as it is a previous generation one, there is an option called migrate. So if you want to migrate this load balancer, click on migrate, launch ALB migration wizard. So with a single click, we can migrate this entire environment to application load balancer. So whenever you click on create, automatically creates as an application load balancer. That is a different thing. That's for migration. So here you can navigate to instances tab, find the status. So both instances are showing status as out of service. Hover your cursor to this I symbol. Instance registration is still in progress. What are all the instances we selected? Those 2 EC2 instances is now registering to this load balancer, right? So once the registration is completed, this load balancer will start performing the health check. And if the health checks are success, it will show in service. See, in service. That means both web servers are able to communicate with this load balancer without any issues. Okay. So now here also you can find the status 2 of 2 instances in service. Let's grab this DNS name and let me give the DNS name here. Enter. See, I'm giving refresh. Just observe this value, instance 1 and instance 2. So when I'm refreshing, the traffic is distributing to both the EC2 instances. When I'm refreshing, the traffic is distributing to both the EC2 instances. And as I told you, in backend, we are going to get NIC cards, right? Earlier, we have only web server 1 and web server 2. We got another, 2 NIC cards that basically for ELB, classic ELB for that. So here in this console, we won't get any option to see the load balancer public IP address. In your interview, you can expect this. Okay, can we get public IP address of our load balancer? See from this console, no. Even Amazon directly tell you we cannot, we will get a public IP address, but we cannot see directly. So you can run like a NS lookup and all. So if you want to depend on network tools, NS lookup, give this, it will show the public IP addresses. So this load balancer in backend, it is using these public IP addresses. So if you go to network interface, see this 3.7.35.154, 3.7.35.154. So these two public IP addresses, backend Amazon using to deliver data from this load DNS name. That is a backend mechanism. If you understand, that is good. Otherwise, just leave it. So see here, this is a DNS name. Our traffic is distributing to instance 1 and instance 2. Due to some reasons, one of the instance is down. So I'm stopping this instance intentionally. So I'm stopping this EC2 instance, and immediately whenever we go here, see, all traffic is going to instance 2 only. And this load balancer, whenever you go here, whenever you refresh, see here, 1 of 2 instance in service. Whenever you go to instance stage, see, out of service. See, this instance is in stopped state. Our instance is in stopped state. That's why it is not going to deliver any traffic to this web server. But in backend, this load balancer continuously perform these health checks. It continuously perform these health checks, right? So again, whenever this instance is alive, whenever this instance is live, so automatically this started sending traffic, right? So then this load balancer will check the health checks, and instance is still in stopped state. Let's wait for a minute or two. So now only instance 2 is giving the output. So all traffic is going to only instance 2. So basically this load balancer uses round robin mechanism. Round robin mechanism means first request here, second request here, third here, fourth here, fifth, sixth. If you got any other EC2 instance, like, for example, you have 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a mechanism it is going to use. So it uses round robin mechanism. So now that instance should be healthy by this time. See here, it is in service and 2 of 2 instances in service. Now, if we go here, if we give refresh, again, it is going to instance 1 and instance 2, right? So this is a high level overview about the classic elastic load balancer. So now you want to remove one of the load EC2 instance from this load balancer. Simple, navigate to instances, edit instance, what instance? Uncheck it, click on save. Only one instance will be part of this load balancer. So to add or remove EC2 instances, you can go to instances tab, edit, you can add a new instance or you can remove an existing one. That is a tab. Health check. If you want to modify any health check properties, you can go and you can do that here. Listeners. See, while launching, we have opened only port number 80. So later on, you decided to add SSL certificate to this. So then you can go to listener and you can open that port. You need to add what is a protocol, HTTP protocol. See what is the SSL certificate you want to give. You need to go and you need to choose that SSL certificate here, right? That later on also we can do that under listeners. Monitoring. So basically CloudWatch is going to monitor all our resources, how many healthy hosts we have, unhealthy host. So what exactly latency we are getting, 300 errors, 200 errors, 200 success messages, how many, that we are going to get a graphs about this load balancer by using CloudWatch service. Tags, if you want to add or remove any tags, you can do that here. So now couple of options on this load balancer. That is, so basically we have an option to enable access logs. So this logging on our load balancer. So logging on our load balancer. So access logs is a service. Access logs is a service where we can enable logging on our elastic load balancing. So if you want to enable that, go here, click on configure access logs. So then enable access logs. In what S3 bucket you want to store all the logs, and what is the log aggregator interval. For every 5 minutes, I want to write all the logs to abhinas.elb is a bucket I'm going to pick. Create this location for me. If this bucket is not available, you can initiate to create this. So I'm selecting it, then click on save. So now whatever the traffic coming on this, so automatically the traffic, the logs will go and will store in this particular bucket. Okay. So along with that, we have another option called stickiness. So whenever you are trying to access this, see the traffic is going to both the web servers. But I have a requirement that once this browser session is stick to one of the web server, I want to send all the traffic to that web server only for coming 1 hour or coming 2 hours. Okay, so in that case, we can depend on a stickiness. So let me share this URL. Whenever you click on this link, I have pasted it in our chat box. Whenever you click on that link, you will get this web page. Even now, if you give a refresh, you will get output from instance 1 and instance 2. Okay, but what happened, for example, user 1 is there. So let's assume he is a user 1. He accessed my load balancer. So what happened? So the request load balancer sent to this web server. So if stickiness is enabled, so this user session is stick to this particular web server only, instead of like, first request will go here, second request will go here, right? If this user giving refresh, instead of that, once session is active for this user, for coming specific duration, the traffic should go to that particular EC2 instance only. That need to happen. So for that, we can enable this stickiness. So under port configuration, I'm going to enable the stickiness, edit stickiness, enable load balancer generated cookie stickiness. If you have an application that generates cookiness, what exactly your cookie name, you can give that. If you have your own cookies, otherwise go with the load balancer generated cookie stickiness. For how much duration? I'm going to give for 30 seconds. Once session is active, for coming 30 seconds, whatever the traffic coming, it goes to this web server only. That is what it is going to happen. But so now edit, I have enabled. So now I navigate here, I'm giving refresh. See here, all traffic going to instance 2 only. If I take another browser, like if I'm trying to access that, it might go to instance 2 or instance 1. See here, within this browser, one session is active. It is going to instance 1. Within this browser, another session is active. That is going to instance 2. So based on browsers and browser sessions, we will get it. So that is a stickiness. So classic load balancer supports stickiness. We can enable whenever you're disabling this. So immediately your traffic will go to both the web servers. See this? So that is a mechanism we have on classic load balancer. Right? So now, any questions on this classic load balancer, guys?
Actually, when we use this mechanism mm, to maintain high availability, or if we are getting more traffic, we are dividing the traffic to two EC2 instances.
In both the scenarios, your required high availability for your application, as well as one EC2 instance is not able to take all the load. So in that case, we are going to distribute our application across multiple web servers, and we are going to.
Can this be controlled by geography, like traffic from a certain geography is distributed to, one instance as opposed to the other?
So that we can configure by using Route 53, first thing. Second thing, if you want to allow or block by using a specific geographical location, we can perform by using CloudFront distribution. That we will discuss in our coming sessions.
Avinash, we just discussed about the health check for the attached EC2 instances, right? So
Yes.
similarly, is there any problems with the load balancers in real time? Will be facing any problems like the load balancer coming down? It's not
Load
active.
balancer is a virtual appliance. We have an availability like 99 point 999% availability for this load balancer. So we cannot experience downtimes. So that is managed by AWS. So they are giving SLA values, right? So that SLA is high. So we don't experience any.
Yeah, and I missed the part. Did you say there is a redundancy on the load balancer level as well, like ELB level? Like if one fails, then is there like a backup there?
No, we don't have that. So the SLA itself is a huge for this load balancer from AWS. So we won't get any downtimes with regards to this ELB. Right. So now let's configure application load balancer. So when coming to this application load balancer, so here Amazon introduced a bit advanced mechanism in this application load balancer. See the traffic we are not going to see here in classic load balancer. In classic elastic load balancer, the traffic is diverting to only particular web server. But in application load balancer, we are going to create a group of resources. Application load balancer or ALB. So whenever we are working with this ALB, same mechanism. The mechanism is going to be same, but a bit advanced thing added here. That mechanism name is target group. So with this classic load balancer, you can deliver only one application at a time. But when coming to application load balancer, whatever the port you want to open, you can open that port, and whatever the traffic coming on that port number, you can send to different group of EC2 instances. So basically we call instances the targets here. So you can create a target group. Let's assume this is target group 1. So this is target group 2. So within these target groups, we are going to have EC2 instances only. For example, here you have only one EC2 instance. So here you have some of the EC2 instances. So now again, same load balancer is going to work here. But whenever the traffic is coming on this load balancer, so whatever the traffic coming on this load balancer :80, okay, I want to send the traffic to this target group of EC2 instances. Whatever the traffic coming on this load balancer with port number 8080, I want to send to this group of EC2 instances. You might have only one or two, that you might have a number of the EC2 instances here, but we are going to distribute the traffic based on the target groups, first thing. And this target group, you are redirecting traffic. Whatever the traffic coming on ELB port number 80, you are sending to this. What are the traffic coming on port number 8080? You can configure to trigger to this target group. So this is a mechanism added on application load balancer. So one EC2 instance can be member of multiple load balancers. That means these two EC2 instances are there, right? I can use same EC2 instances for my application load balancer also, whenever classic ELB is up and running. So otherwise you can delete this and you can configure. So I'll keep it active, this classic load balancer, then click on create load balancer. I am selecting application load balancer. See, it supports HTTP and HTTPS traffic only. Then click on create. So now, what is the name you want to give? App ELB is the name I am giving. You want to make it as an internet facing or internal. Here we discuss that intranet or internet. So this is like, internal ELB. This is internet facing ELB. Internet facing ELB. This is an internal ELB. So I'm going to make it as an internet facing. So I'm going to select that. And this load balancer is going to support IPv4. If you want to get support from IPv4 as well as IPv6, you can select dual stack. IPv4 is good with that. Good at moment. So listeners, so port number 80. So again, I'm mentioning, if I want to open HTTPS, I can open this. In next step, I can configure that like, SSL. So go with the port number 80 at moment. So now, what are all the load balance? What are the subnets you want to make part of this load balancer? I'm going to make AP South 1A as well as 1B part of this load balancer. So then add-on services, we'll talk about this in our coming sessions. We have a session on global accelerator. We will discuss later. Then click on next. Leave this, ignore this error as we haven't opened any HTTPS. We will get this error. Then click on next. So here, what security group you want to use? So I'm going to use ELBSC. So you can create a new security group, that's absolutely fine, but port number 80 must be open. So I'm going to choose ELBSC, that already available, right? I'm going to pick that. So then click on next. So now here it is asking me to choose the target group. So earlier till here the steps are same. After that we have configured like, the health check. So the health checks also you can configure the same page. But here we need to choose, okay, what is the target group name you want to give here and you want to give here. How many instances you want to add, that we can define. So I'm going to create a new target group. So the target group name, I'm going to give similar, like, TG1 I'm going to give. So TG1 is a target group name. Now, how these targets are going to be added to this target group? By using instance ID or by using IP address. So which parameter it is going to take to register this target to this target group? So we can register by using instance ID or we can take IP address. But whatever the one you are selecting this, we cannot change. So I'm going to take instance ID. Lambda function, that is completely different, the different mechanism we will talk, we won't discuss that now, we'll talk later. So I'm going to take instance now. So it is going to use a protocol port number 80 protocol HTTP. So protocol version it is going to pick automatically. Then scroll down. What is a health check? I want to perform health checks to index.html. Expand advanced health checks. So then how many healthy threshold? How many unhealthy threshold? What is the request timeout within 2 seconds? When within 5 minutes it need to give reply. Success codes. So if health check is success, what is the status code you want to write? Okay, I want to write status code as a 200. See, 200 to 299 is a okay or success status codes. So you can write anything between 200 to 299. or else for all success codes, you can even give only one. So I'm giving 200. That is absolutely fine, or you can just ignore, go with the default values. 90% of the times we go with the default value. Right, then click on next. So I'm creating a target group. Instances register to this target group by using their instance ID. By using this instance ID, it is going to, if you are selecting IP address, it is going to register by using this private IP address. I'll create another one by using IP address. I'll show you. Then click on next. Now you created a target group, fine. But what are all the targets you want to add? So I want to add both the targets. So web server 1 and web server 2 to this. So click on add to registered. I have added both. If you don't select add to registered, if just selecting this click on review won't help us. So it won't add. So make sure you click on add to registered. So here it got added. Now click on review. Load balancer review, application load balancer, internet facing, port number 80 traffic it is going to take, it is going with the IPv4. Within this VPC it is going to run, and two subnets is part of this. This is a security group, is taking all the traffic from the load balancer, and these are the routing, right? So now these two targets are registered to this target group. What are the target group? We are creating it here, new target group, then click on create. Now, one load balancer is created with only one target. So this part is completed now. One load balancer got created. It came with one target group and two instances added here. And it is going to take traffic on port number 80. So now let me quickly launch another EC2 instance. Of course, one EC2 instance can be a member of multiple target groups also. But just to make the things clear, I'm going to do one thing. This is my 8080 instance. This is a user data I'm using. Click on next. Next, 8080 instance. Next, I'm going to choose same security group, web server SZ. Review launching using an existing key pair. All right, click on view instances. Let's keep that. Let's test the output of the thing we configured so far. So this part we done now. So now let's navigate to target groups here. You have a screen below to the load balancer, that is a target group. Here is a target group. The target registration type is an instance and it is taking all the traffic on port number 80. It is running within this VPC. It is associated to this load balancer. Now navigate to targets. Both instances added. Health check is going to happen here. So both are target registration is progress, and see here, both are healthy. Fine. If you want to add a target or if you want to remove a target, this is a page. Select this, deregister. Or if you want to register a new instance, click on register targets. What target you want to register? For example, you want to add this one also. Select it, include as pending, click on register. So you will get that instance also here. So monitoring. CloudWatch is a monitoring service throughout our AWS environment. How many healthy hosts, unhealthy hosts, everything we are going to get it here. So now our load balancer is taking all the traffic on only one target group. So let me delete this classic load balancer, deleted that. So here is a listener. Whatever the traffic coming on this load balancer on port number 80, what it is doing, it is forwarding all the traffic to target group 1. Okay, so let's navigate and grab the DNS name of this load balancer. This is the DNS name of the load balancer. Go back here, give the DNS name and see that here See, my traffic is going to instance 1 and instance 2. See, even if I gave explicitly colon 80, when I click on enter, see, same thing is happening. So now whatever the traffic coming on port number 80, it is navigating to this target group. See, whatever the traffic coming on this load balancer port number 80, it is going to this target group. Within this target group, how many targets are healthy? Those all targets will take the traffic. So instead of directly sending the traffic here to these individual EC2 instances, we created a group. Health check is going to happen at this group level, and whatever the traffic coming, we are sending it now. So I hope this part is clear. Now I'm going to configure this target group. Okay. Whatever the traffic coming on the same load balancer on port number 8080, I want to send it to different target group. For that, I need to create a target group first. I need to add a target, at least one target here. Then I need to configure to receive the traffic from this load balancer. That's what I'm going to perform now. Okay. So navigating to target groups. Click on create target group. So what is the target type? You want to go with the instance or IP address? See, earlier we selected instance, right? This time I'm selecting IP address. Okay. So then click on. So basically there is an advantage with this IP address mechanism. So you have a server that is running in on-premise. So you can select that IP address and you can choose that. Supports load balancing to VPC and on-premise resources also. But this one, it supports only specific VPC resources only. So let's pick that IP address at moment. Then scroll down. What is the target group name? I'm going to give TZ2 as a target group name. Again, protocol, go with the HTTP protocol, port number 80, and VPC, go with the default, go with the protocol version HTTP 1. Then what is a health check? I'm going to perform health check on index.html. Don't give any typo. It will lead to health check failure and your instance stops sending traffic to that. Advanced health check settings. So again, you can go here, how many healthy threshold, unhealthy thresholds, you can define that. Right. So then click on next. So now within this network, within this VPC, what IP address? What is the IP address of your EC2 instance? That IP address you need to add here. So this 8080 instance, this IP address you need to pick. You need to add that here. Click on include as pending below. See this IP address where it is running in episode 1A. It is running in episode 1A. That is going to take. So then click on create target group. Now one target group got created. See this target type is IP. Whenever we navigate here, target type as a IP, one EC2 instance is registered. And what is the status? It is unused. Why? Because it is not sending any traffic to any of the load balancer. Whenever you are sending traffic to this load balancer, then only the load balancer will perform the health check. Then only it will declare that instance as a healthy or unhealthy. See, status, target group is not to receive any traffic from any load balancer. So it must be receive traffic from the load balancer. Okay, so then only we will get the status as a healthy or unhealthy. Why? Because load balancer only will tells this healthy or unhealthy. So that's the reason. So now target group 2 is ready. Similarly, if you want to use target type as an instance for a new target group, click on create target group. I'm selecting instance, give a name TZ3. So now scroll down, I'm going with all the default options. You can leave this also blank, then click on next. So here it shows all the instance. Okay, I want to make these two part of the target group 3. Then scroll down, click on include as pending below, click on create target group. So I created another target group, target type as an instance, and this contains web server 1 as well as web server 8080. So similarly, one instance can be member of multiple target groups. Okay. So now Let's navigate to our load balancer. So far, this is what the output. If we are trying to access the same via port number 80, if I gave colon 8080, if I click on enter, see it's trying to load, and it's going to fail. Now I'm navigating to listeners. I'm going to add a listener. Click on add listener. So one port should be open only one time on load balancer. 80 is already open. What I'm doing, whatever the traffic coming on port number 8080, whatever the traffic coming on port number 8080 on this load balancer, redirect all the traffic to this target group. Go here, click on forward the traffic to TZ2. Then scroll down, save, add listener. Now, as per this configuration, whatever the traffic coming on this port number 8080 of this load balancer, it is forwarding to TZ2, target group 2. What are all the instances registered to this target group 2? Those should give reply now. So if we go here, if we give refresh, still it is not delivering any web page. But if you observe, we got a little triangle mark here. So that little triangle mark comes whenever the required port is not open in the security group. Whenever you click here, see the security group of your load balancer does not allow traffic on this listener port. What is this listener port? 8080. That means this load balancer security group, this security group is not open with port number 8080. Navigate here, open inbound, go to inbound rules, add rule, custom TCP 8080 for everyone. Scroll down, save rules. Now, this URL is working. See this. See, whenever you are using 80, it is going to instance 1 and instance 2. Whenever you are trying to access 8080, it is going to different target group. And what instance is registered within the target, we are getting that output. Similarly, I have target group 3 also, right? I have target group 3 also. So now I want to configure another thing that under listener, add another listener, tell me any port number. Anything between 0 to 65,535. So let me take 8888. Whatever the traffic coming on this load balancer 8888, I'm going to redirect it to, I'm going to forward it to, sorry, we need to use forward. I'm going to forward it to, so target group 3. Then add listener. Again, a little triangle. The reason is this security group ELBSG is not open with 8888. So now same URL. If I give 8888, it is not delivering. Now I'm opening that port. Custom TCP 8888. I'm opening it for everyone. Then scroll down, save rules. Right. So go back here, give a quick refresh. So then you will get response from, see this, web server 1 and 8080 instance. Why? Because that target group contains those targets. Okay. So by using this listener mechanism, we are going to perform these redirections. Now give refresh, this exclamatory won't appear. It's gone. Why? Because the port number is open. Similarly, see in our organizational level, we are going to open many port numbers based on our application team requirement. Okay. So that is another thing. So that is a listener mechanism. This is an option we have. We don't have on classic load balancer, but for application load balancer and network load balancer, yes, we have these options. Okay, so this is elastic load balancer. Now, if you want to configure stickiness, for example, on this particular port number, multiple web servers are there. So the traffic is flowing to both the web servers. So I want to enable stickiness. So stickiness instead of load balancing level, we can enable a target group level. Navigate to target group, group details, scroll down to bottom. Here we have an option called stickiness. Click on edit. So now what is the stickiness duration you want to give? Enable this load balancer generated cookie stickiness, and once it is activated, it should be available for coming 10 minutes. Then save changes. Now, if I go here, if I give refresh, couple of requests will take, see, it will take effect. Now, just give a hard refresh. What target group? Target group 1 only, that is on port number 80. See, now it taken effect. So all traffic is going to my instance 1 only. But within this target group, we have 2 targets. So as we have enabled stickiness, it is going to only 1 web server. So instead of load balancing level, we can manage that at target group level. First thing. Second thing, so this application load balancer supports 2 algorithms. One is round robin algorithm and second one is least outstanding request algorithm. So least outstanding request algorithm. So which one you want to go, that we can change. So if you want to change that algorithm, select that, save changes. So if you want to understand that least outstanding, right? So least outstanding request is an algorithm. So it sends traffic in this manner. So if you're taking network load balancer, it works flow hash flow algorithm. Network load balancer, flow hash or hash flow algorithm. So when coming to this least outstanding request, based on the resource utilization, see, when coming to round robin, you have 3 instances. First is going here, second is going here, third is going here. So based on the count, if you have 3 instances, 33 here, 33 here, 33 here. Okay. When coming to least outstanding request, it redirect based on the resource utilization. See here, even this resource CPU utilization is 99%, still it is sending traffic 33%. So whether you are having high load or low load doesn't matter. Based on instance count, it is going to send in least round robin mechanism. When coming to least outstanding mechanism, see, this CPU utilization is as it is a 90%, it sends less traffic compared to the remaining one. Why? This resource utilization is 85%, 85%. But this one, 90% only. So based on that, it is going to redirect. So this load balancer keep on tracking the usage of this resource also. So based on that resource utilization, it will send. So this is an example for this round robin and least outstanding request. When coming to flow hash algorithm, so that involved with lot of things that don't try to understand. So it will send traffic based on the this mechanism. This is a flow hash algorithm. How hash algorithm is going to work, data blocks are going to be there. So mathematical hash function is going to run in backend. So that is going to send. So don't ask me, even I don't know these algorithms. Right? So we have an option to change the algorithm of an application load balancer at target group level. And if you want to enable logs under attributes, we have an option called access logs. Go and edit, select the access logs. In what S3 bucket you want to? Okay, I want to store all these things to an S3 bucket called avinash.elb. If you don't have that bucket, you can enable that, then click on save. So now about this load balancer also, all the traffic is going to store in our S3 bucket, right? So one final thing we'll talk about that security setting. So when coming to these security group settings, see so far, like we have opened port number 80 for everyone on our EC2 instance. So what is our requirement? Whoever want to access our application, they should access our application by using this Elastic Load Balancer DNS name only, right? But some guys, what they are doing, instead of accessing our application by using Elastic Load Balancer, they run some NS lookup tools and all. They came to know about IP address of our EC2 instance, and directly they are accessing our EC2 instances. So when this end customer directly trying to access our EC2 instance, this should not work. They must go via Elastic Load Balancer only. Okay. So for example, one celebrity is there, right? One hero is there or celebrity is there. Like, here general public is there. Whenever these general public knows their identity, they can contact them directly, right? But what this guy want to do, they should not directly access him. Whoever want to meet him, they want to contact, like, so one manager, his manager. So this manager is available to everyone. Anyone can call to this manager. But this celebrity is going to available to this manager always. So now this should not happen. Whoever want to access this celebrity, they should go via manager only. So in that case, we need to modify this EC2 instance setting. This is our EC2 instance. At moment, it is open for everyone. Even if we have a manager also, as he is open for everyone, anyone can go and access it, right? See now, our EC2 instance, this is our EC2 instance. These EC2 instance security group, port number 80 is open for everyone. So anyone can go and access this EC2 instance. This URL is going to work without any difficulty. See, this URL is working, and another instance URL also works without any difficulty. This URL also working. So this should not work. Whoever is using this load balancer URL, only for them, that website should be delivered. So for that, we need to set our security groups accordingly. We need to adjust our security groups accordingly. So that's why I told you. So we use same security group for all our web servers. So now pick the security group you used for all your web servers. So now at moment, it is open for everyone. So now if you delete this HTTP, so your web server also won't, your load balancer also won't communicate. So you will land into an issue that application is not going to deliver. But instead of that, add a new rule. Whatever the traffic coming on port number 80, whatever the traffic coming on port number 80, instead of sending to everyone, do one thing, either give your entire VPC CIDR block that we don't know at moment. So give security group of your load balancer, ELBSG. So what it is doing, whatever the traffic coming from your EC2 instances, all the three EC2 instances is using same security group. Whatever the traffic coming from that EC2 instances on port number 80, it is delivering to another security group. So for what are all the resources this security group is associated, those all resources will get the traffic. See now, as per this setting, this URL, are we facing any difficulty? See, no difficulty. This is working without any issues. It's working. But this one, is it working? It's trying to load, and it's not going to work. So this load balancer must have the security group. This is a ELBSC. So load balancer will get all the traffic from these all EC2 instances, but not any other resources. See, this is not going to work. This is not going to work. So what we are doing, we are configuring this manner. This celebrity, whatever the phone number the celebrity have, that phone number is with this manager only. If we have two managers, yes. So they need to maintain security groups, like, or this manager might maintain multiple load balancers also, multiple celebrities also. So it all depends on. So this celebrity or this EC2 instance, what are the traffic coming on port number 80, that must deliver to ELBSC. This mechanism is very, very important. In our coming session, whenever we are configuring our application server and database servers, we are going to follow same mechanism. And it is very, very, very important for your certification exam also. And make sure you mention this in your interview as well. Okay? Right. So, sorry, this is a bit lengthy session. It's almost 1.5 hours. Sorry about that, guys. So that is all about classic load balancer and application load balancer. So make sure you configure security groups accordingly. So for today, the task is, launch multiple EC2 instances and make it as web server. Right. So then practice with application load balancer, guys. Create application load balancer. Create application load balancer. Port 80, deliver to instance 1. Port 8080, deliver to instance 2. Instance 2 means create a target group for this, create another target group for this. Okay, so test that and make sure you configure security groups as discussed. So instances should not accessible using public IPs, but should deliver without any issues using ELB DNS name. Right. So this I want you to configure. So in our tomorrow session, initially I'm going to show you with the network load balancer. The mechanism is same. Everything is going to be same. I'll show you that. So then after we will start discussing about CloudWatch, then auto scaling group. So that we will discuss tomorrow. So any questions before closing the session, guys? And load balancer comes under free tier eligibility. You are going to get 750 hours. That means one load balancer, you can use it for 1 month. So as we already spent 18 days, 19 days. So for coming days, you can even have 2 load balancers also, that you won't get charged anything. Any questions before closing the session?
So Avinash, while configuring the security group for load balancer, right? So
Yes.
we are accessing it from the browser, right? But you configure it for custom TCP, right? Is there any specific reason for that?
Custom TCP, where I mentioned custom TCP?
While configuring the security group for load balancer, right?
This is a security group of my load balancer. Yeah.
Yeah. So here you see the type is custom TCP.
This one.
Yeah, yeah.
Port number 8888 is not fixed for anyone. See. So we have port numbers from 0 to 65,535. Port numbers are there. 0 to 65,535 TCP IP ports are there. Okay. So among that, some ports are dedicated. For example, if you are taking SSH port number 22. So as it is a dedicated one, Amazon is giving that. See, so they are giving SSH. But apart from SSH, for example, I want to open port number 23. Is it available here? No, right. I want to open a port number, so I can pick that. I can do whatever port I want to.
Okay, so it is like if I choose STTP, it will take 80 only. That is why you are taking custom TCP because you are giving a
Yes.
different input. Okay, okay. got
Yes.
it. Got it. Thank you.
Any other questions, guys? Can you please upload images as well? Yes, I'm going to do that. So that's why I have saved that images into my local machine. And I already did that. All right, so that's it for today's session. See you again tomorrow, guys. Tomorrow we will discuss about CloudWatch and all. Right? So, yeah. Any questions?
Manoj here. We want to quickly look at.
Yeah,
website.
Manoj, you have your resource ready?
Yes.
Okay, can you 1 second? Oh, share your screen. I made you as a co-host.
Sure. Yeah. Can you see my screen?
Yeah. So, have you connected your EC2 instance?
Yes.
Show me that. Show me. Service status. Okay. Service HTTPD. Can you go to CD var www.html? Enter. ls. Create VM index.html. Press I. Write something. Okay. Now open the browser. Give instance public IP address.
It's all right.
Yeah. So your load balancer is working. Can you click on that load balancer tab?
Oh, it was working when you were
Can you
showing
go
your
to
question.
first tab? First tab. Okay, you check my load balancer. So, 1 second. Security. Yeah.
Yeah, the 4080 as well.
Okay. Can you go to VPC? Search for VPC in search box. In search total top. Yeah. Open that in new tab. Select that internet gateways. In left side, you have internet gateways. Select that. Go to root table above internet gateway. Left pane. Select routes. Below. Here below.
Yeah.
Yeah. Scroll up.
That's all, yeah.
We have 3 buttons. You can scroll up that. 3 buttons there. Or do one thing, edit routes.
Okay.
Remove that second one. Add routes. 0.0.0.0. Select target. Internet gateway. Select that. Second, yeah, save routes. Close. So can you open command prompt? Not this one, your local machine one. You connected to instance here, right? Take another terminal. Yeah. You ping your EC2 instance IP. Can you go back to your window, security groups, security group of the EC2 instance. Select that. Edit inbound rules. Add rule. Select there. All ICMP IPv4. Everywhere 0. Yeah. Save rules. Go back to terminal that you pinging. There is no issue with your communication. So now you're able to ping that EC2 instance. Go back to your web server. Try to check the output of your web server. Take another browser. What is that IP address? 3 dot, 1 second. So 3.140.252.178.
Right.
It's working. Seems there is an issue within your device.
Oh,
It's working, right?
right. Should we disable any ad blockers or something like that?
That you need to check. I think that's what browser you're using.
This is Chrome. I'm unable to open it in Chrome, but I tried to open it in Safari. It worked.
Yeah, there is an issue with your browser. So there is, see, what I try to do is I try to verify there is a communication issue from our local network to this VPC. So for that, I got a doubt. So that's why I asked you to remove and add internet gateway. Basically, internet gateway is an entry and exit point to our AWS environment and outside world. That's why we created that. We deleted the existing route and we created. That's the first thing. Second thing, I want to verify the communication from my local device to the EC2 instance. For that, we can use ping. So, but ping need to work, ICMP traffic must be allowed on our EC2 instance. Before opening that ICMP, ping not worked if you observe your terminal. So later on, we are able to ping. Then I have confirmed that the communication is good from my local machine to EC2 instance. So as that is pinging. So then after we concluded that the service is up and running, the communication is there. So that is a problem from your browser. So I tested in my local machine. As it got worked, we concluded that it is a problem from the browser. Right?
Yeah. So is there a way to fix? Because I'll be regularly
Browser,
using.
I'm not sure. Just reset the browser. Reset entire browser to default setting or just uninstall and install the browser. That should fix the issue.
All right.
Try changing your HTML, right? I mean, giving the proper HTML tags. Maybe browser is not understanding because you have added just the H1 tag.
But same Chrome I am also using, right?
Oh, okay.
Same Chrome, you are using, same Chrome we are using. So he might have some add-ons that is blocking. I'm suspecting that. So if you reset that browser to defaults now, it should work. If it is not working, yeah, there might be like a bug from Chrome for Mac OS.
Sure. Yeah. I'll try to.
Just reset, that should fix most of the issues. We'll see that.
Okay.
Yep.
All right. Thanks.
So yeah, that's it for today's session. See you again tomorrow, guys. Thank you.